Jason, thanks for joining today to talk about main shaft assemblies, and pictured behind you is a part of that assembly. And I just have a few questions that I think would be very helpful to hear from you on. So again, thanks for being with us.
Hey, thanks, Sam. Appreciate you putting this together. Looking forward to answering any questions you have.
All right, great. Well, let's get started. So Jason, there's a lot of discussions about different bearing types, from asymmetrical to symmetrical to split. What's your opinion about the importance of that bearing type for the main shaft assembly?
Well, Sam, there's a lot of different bearing types out there in the aftermarket upgraded bearings, but my point isn't really what one's the best upgraded bearing. My point, Sam, is the bearing is only going to be as good as the journal it's put on. And the point I'm trying to get across is, what needs to be done to repair or qualify a main shaft bearing journal before you put any bearing on.
And tell me a little bit more about the journal. What exactly is the journal?
It's the inside of the bearing, or the bearing inside diameter goes over the bearing journal, which is on the shaft itself of the main shaft assembly.
What exactly do you have to do to a journal to make sure it doesn't become the weak point of the assembly?
The journal needs to be requalified. And there's three things you need to do when you review a bearing journal, whether it's on a main shaft or on any shaft or in any gearbox, any application. First, you need to dimensionally make sure it passes to meet the fit spec. Second, you need to inspect the surface and the subsurface to make sure it's not in an advanced state of fatigue. And the third thing is you got to make sure the surface finishes there after it's repaired, or if it's not going to be have anything done to it, you need to make sure it's got adequate surface finish to let that bearing seat and ride properly.
What are some of the right questions to ask as you look for a supplier to fix that assembly?
Well, I think you need to ask and look at, what's their repair process? What do they do in-house? What do they outsource? What are their capabilities from a QC and inspection standpoint? Are they only doing dimensional checks? Can they do any metallurgical inspections? Can they do any UT? Can they do any crack check? And I think the best way to understand that is to just ask to review their rebuild process and what the scope of work, what the full scope of work is that they do.
Can you describe some of the different forces on the main shaft assembly?
Sure. So the main shaft sees a lot of different forces. Obviously there's an axial load, that's the weight downward on the main shaft and the bearing of the main shaft caused by the weight of the rotor. There's also a thrust load that the main shaft assembly and bearing see, and then there's also some other more complex forces that main shaft assembly sees, as the cantilevered weight of the rotor in rotation causes what's called a bending moment.
What are the different methods of welding something back up, and do you have a preference in this application on a main shaft assembly?
Yeah, we do. If you're gonna build a shaft back up to the original diameter and machine it or turn it back so it can take the OEM spec bearing, you really need to make sure that the whole fatigued and failed zone on that shaft journal is machined off. Otherwise, you're just basically patching it, which is bad because it doesn't arrest or remove what's failing. It just fills the gap, so to speak, so the bearing fits when it's assembled, but everything can still continue to fail when it goes back to service. So we definitely recommend measuring and understanding the complete depth of fatigue and failed material on the journal, then removing it, machining it off completely. That's the first thing. And then the second key part is that the material selected to build the shaft back up closely matches the base material. So you need to make sure the alloy being applied is of the same metallurgy as the base shaft so that it has the similar properties when it's installed, and bonding strengths and toughness, and basically acts and moves as part of the shaft, not a patch.
Are there different ways to repair things if during those inspections and assessments you find something wrong?
Yeah, there is, and there are several different repair options. There's removing the failed zone of material by machining it off and then building it back up. And then some sort of cold working process like roller burnishing should be done to toughen that surface and get the surface finished where it needs to be, so that it can handle, go back into service and be as good, if not better, than it was originally. Another repair option is to remove the material, still go through a cold working process, and then to toughen it back up with the surface finish on the journal, and then install a bearing with a slightly smaller inside diameter. So that would be an undercut, and then again you still need to do some sort of cold working process to address the surface of that journal, like roller burnishing or deep rolling.
Okay, well, thanks, Jason, for some of those questions today. I appreciate you enlightening me on a little bit more detail with what you do in the machine shop with the main shaft assembly. Are there any other considerations that need to be made?
I think that covers the big items, and thanks a lot, Sam, for sitting down with me and taking some time to talk about main shaft assemblies.